Placing sounds in space is an essential part of sound design. Now we're used to this with stereo effects where you hear slight differences in your left and right ear and your brain kind of creates a sense of where the instruments are. Of course, it's possible to place instruments elsewhere in 3D space around the listener. Some of the modules available for this, like the Warren Soundstage or ALM Jumble Henge, allow you to place sounds to the back, to the front, higher or lower than the listener's ears. But they tend to be fixed positions. You can't modulate it, you can't have them move around. But the Neuzeit Quasar is different because it allows you to move sounds in 3 dimensions and animate them in 3 dimensions. So sounds can be behind you, in front of you, above you, or below you. And they can move slowly or quickly, and they can move in sync to external events. In today's video, I'm going to take you through how Quasar works. We're going to explore the user interface, which is actually very intuitive, as well as being one of the prettiest modules I have. And we're going to make some sample patches and some music along the way. Neuzeit sent this module to me to do some experiments and videos with after I chatted with them at Superbooth, so thank you to them for that. So let's get started with some patches. The menus are only 1 level deep. They're easy to navigate using this control here. You press the knob to select the parameters. You can go through them and notice how the colors here on the rings change to indicate the current settings that are on those values. And as you adjust them, the rings are also reflecting the current parameter value. So it's actually really, really pretty, but also intuitive to look at. You've got 2 menus for each of the Quasars, Quasar 1 and 2. 2 menus to say how the inputs are routed and filtering, 2 menus CV1 and CV2 that let you do CV mapping because there's a mod matrix inside this, and that allows you to use these 2 CV inputs here to route to different parameters inside the module, for example the speed at which sound is moving around. Well, the other nice things is you can load and save presets, and it's very straightforward. You just go down, you select, you'll start with the init preset, and they're stored on an SD card in the back of the device, so you can take it out, you can send them to friends or whatever. Let's take a quick look at the audio flow. As you can see on the diagram I have here, each of the inputs routed through a filter, which you can set in the input menu here. Input 1 allows you to choose different filter types. And I turn the big knob here to adjust the parameter. So that's a high pass filter. And that's the input 1 to Quasar 1 mapping, or input 1 to Quasar 2. Notice again, as I adjust the high pass filter, the parameter here is really illustrated well by the color on the wheel around the knob. And if I adjust the gain for that, the same takes effect over here. So these are used very, very well, I think, in this module. If all of these are down on 0, you're not going to hear anything. And if you don't hear anything, that could be why. So check that. You also have an overall output level here, which you can adjust so you don't overdrive your output stage. And you can adjust the relative gain of the input. So for example, if input 2 is down to 0 and 1 is there, you get obviously a gain here and nothing here going into the second Quasar. Okay, I've got this patch set up. Let's now take a look at what effects all of these settings have. So here it is with basically no movement, fairly dry. Bit of filtering there, but other than that, we don't need to pay too much attention. We're not looking at QPass today. Let's go in and adjust Quasar 1. Now, first of all, we can adjust where the sound is around our ears. So let's take a look here at the angle setting. And you'll see it here, it's set to 65 degrees. And the way this works is you use polar coordinates. So you might be used to X and Y coordinates for setting parameters for things, say, in a geometrical sense. Polar coordinates work better. They basically represent the sound location as a degree around your head from 0 to 360. Imagine a circle around your ears, and an elevation up or down, up to 45 degrees up or 30 degrees down, and a distance. So the distance is how far that sound is away from your head, from about 20 centimeters to about 10 meters. Okay, now let's see what effect adjusting these angles in the Quasar menus have. I'm going to press and go into Quasar 1, and so I've just got Quasar 1 patched in right now using input 1. I've dialed down the effect of Quasar 2 and center, so Quasar 1 knob is turned up, and I've got my input gain set. When I hit play, if we go back to the main menu, you'll see the input and output levels are nicely in the green, and so that shows I'm not clipping on my input. One way to visualize the parameter you're adjusting is to imagine that these knobs are the center of your head and the sound position is wherever the illumination is. So right now when I hit play, the sound should be straight in front of us. And that's where it appears. Let me just dial this around here. Now you can hear the sound moving. Now it appears to come from behind my head a little bit. And now it's moving over and back again. Now one of the nice things is Quasar has a built-in LFO for this, so if we just click here, straight away we're beginning to move the sound. So we don't even need to do LFO mapping. We're saying, let's just move that sound in space. Look at that beautiful illumination we're showing you as that sound moves. So now we should start hearing that. Now when I turn the knob, I'm adjusting the speed. Too fast can get a little bit much. Now look, see how fast the sound is moving. Now you're really going to hear it flying around your head. Might make you feel a little bit nauseous. Let's go to the next menu item. This lets us set the distance of the sound. Naturally, if it's closer, it's louder. And as we set it further away, the sound, turn up the volume a little, the sound gets a lot quieter. And you can go up to 10 meters away, which is pretty far away. I generally keep it about half a meter away. The room parameter lets us adjust the damping of the high frequencies. And so if you imagine reverb is echoing around inside a room, this is the amount of those high frequencies that are being reduced every time the sound bounces around. And again, our brains use this to localize sound in space around us. Let's take a look at some of the other parameters on the next menu is room damping and room size. Room size is the length of the reverb tail. So if we turn this all the way up, it's as if the room is constantly echoing, and our reverb grows and grows. And this is the damping effect. So how much of the sound is lost each time you get an echo in the room, if you will. You turn down the damping and turn up the reverb, you just hear it kind of, you see it building. Can you hear it? And then turn up the damping. And the reverb tail starts to get killed away. You want a little bit of reverb on sounds. You don't want it to be completely dry because sounds do exist in real space. And unless you're in some sort of anechoic chamber doing audio testing, there will be echoes and reverbs. So therefore you do want a little bit of reverb. And so probably leaving these around the default is ideal. Finally, we come on to the LFO mapping. Now this is where life gets fun because the Quasar has built-in LFOs, ramp up, ramp down, random values, slew values with jitter values. These allow us to adjust other parameters. Now we looked at already how we could adjust the location of a sound back at the first menu by using the auto angle. And you see that it's still working away there, happily animating. We can add an LFO on top of that. So while that's moving the sound around, we can add another LFO. To set an LFO, we first of all have to choose the type. So I'm going to choose random to just randomize that movement we see on that Quasar. And we can speed sync it so that it's actually synced to an external clock. For now, I won't do that, and I'll show you how to do that in a second. I'll turn the parameter here, and this allows us to set the speed of this LFO, so we'll make it reasonably fast. Now, the next parameter shows the modulation depth, so we're going to modulate the height up and down a little bit, and we'll modulate that angle at about 50% onto the angle. Now we're going to randomly modulate on top of that existing movement of the sound angle. We could also modulate, for example, the distance. So this is your mod matrix, okay? Now, when we go into the Quasar, you can see it, the sound is still moving, but now it's going to jump. Did you see it jump there? And that's because we've applied a little bit of a random modulation to it. Okay, we've looked at using LFOs in the Quasar. Now let's look at how we can add external modulation, either clocking the internal LFOs so they're clock synced to an external clock, or by using LFOs that we have somewhere else in our case if we wanted to use that modulation. In the first case, let's start with simply clocking the internal LFO. So we have Quasar 1 animating away, moving the sound around our heads. But this time, instead of setting the speed directly here using this parameter, we want to clock sync that to an external clock. To do this, we go into the Quasar 1 menu and we use the parameter menu to skip down to the LFO settings. And previously we had looked at the ramp and random LFOs here. Now I'm going to turn on speed sync. So we'll just click that and you'll notice a little X appears here. Now speed sync syncs the LFO to an external clock source. And I'll show you how to set the clock source in a second. But first we need to set the multiplier. And we can use the big knob now to adjust either the multiplier or divider of the clock. Now we need to set the target of what CV1 controls. So we've set what the LFO is doing on the Quasar, but we still need to connect it to that CV. And right now the target is set to none. Now if you wanted to just modulate the actual value directly, you could set the target to whatever you wanted to, height or angle. But we want to clock it, so we're going to rotate this knob here till we get to LFO clock. Each CV value, each control voltage value, can have up to 4 targets. So you could also clock the LFO, say, for Quasar 2 off CV1, or you could map it somewhere else. So if you had a value coming in here, you could map it to multiple parameters in the Quasar at the same time, which is actually quite nice because it saves you having to have multiple patch cables flowing around. Let's go back now to our Quasar, and now we'll see, once the clock starts, the animation of the sound in space. See there now, it's kind of jumping left to right because we had set the clock multiplier here to a certain speed. Now we get a bit of a tremolo effect when I adjust the number of the clock multiplier or divider on the LFO sync setting. And to see the animation, go back to the Quasar. Alright, let's look at direct modulation. So rather than clocking the internal LFOs, let's look at sending a triangle wave from this LFO now into our Quasar directly to directly modulate the parameter for the sound location. We go down to CV1 now, and we're going to, instead of mapping the input to the clock for CV1, let's map it to the angle. There we are. So the input here is now mapped to the angle, and I'll set the modulation amount to about 60% or so, 65%. So we'll see, if we go back up to Quasar 1 now, in response to the speed of this LFO, the movement of the sound, I can turn up the speed, and we start seeing that LFO animate the sounds. That shows how we can move sound using external modulation. Like I said, there was multiple destinations for those CV inputs, so let's also map that CV input using CV1 target 2. So now I'm mapping CV1 onto something else. I'm just going to map it onto the distance. Now let's go back to the Quasar and take a look at that happening. First of all, we'll see the angle of the sound automating as before because we're modulating it using CV1. So we still see this moving as we would expect. Now let's take a look at the distance parameter. It's also going to slowly move. Watch how this animates and fills in. And that shows you that we're now animating the distance of the sound, and you do hear it moving subtly as the sound moves around your head. So that shows how you can map CV inputs onto multiple internal destinations and create a lot more movement with just one simple input. We can also send drums in, so let's do that. I'm using my LXR drum module here from Erica Synths. This is going to go into Quasar 2 for input 2. And I'm just going to turn down the input on Quasar 1 right now. So all we're going to hear are those drums moving. The other thing I did was I followed what we did a second ago. I took a second LFO here, moving at a slightly different speed, and I'm using that to modulate CV2. It's going to modulate the position of the drums and also the room size, so we'll get a bit more reverb added over time. Let's go back now to our input settings, and we can watch. We notice that the input is only on the right-hand side here, because we're only taking input from Quasar 2, and our output levels are a little high. Maybe I'll just turn them down there because it's just popping into the red. We don't want to blow the levels out. We go into Quasar 2. Remember, Quasar 2 is for our drums. There's our drums moving around, not too much because we don't want it getting too wild. We could turn on that animation already, and we'd see the drums moving around us. Maybe we'll leave it that way just for purposes of demonstration. Now let's bring up our melodic amount using the input gain control on Quasar 1. I go into Quasar 1 here now. As you can hear on Quasar 1, that sound is moving because, of course, I set a mapping for CV1 here to map to the angle. I could maybe even bump up the modulation amount. And that then means that the external LFO over here will control the position of the sound. So if we go back up to Quasar 1 and look at the position here on this dial, you see how it's moving. I can speed that up. You can get a tremolo effect. Do the same with the drums. Kind of gets a little bit crazy. If you want to add a center sound, in other words, a sound that's not moving, bring up center. And that sometimes can help if you're grounding sounds. You can hear the reverb tail dragging on much longer now as I change the notes. Well, I hope you found today's video useful. If you're interested in binaural or 3D sound design, this is very much a module you'll want to check out. It moves sound around in space very easily, it's very straightforward to set up, and the user interface is quite intuitive. I did find the height adjustments didn't really have a huge effect on the sound, but definitely the distance, the angle, and the reverb were very, very noticeable, as I think you heard in today's video. This is probably not a module for everyone. It's probably not going to be in every single setup. But if you need something like this, this is one of the few modules that probably does everything you need with a very nice playable control interface that you can use while performing. Let me know what you think. Don't forget to leave some questions or comments down below. Always happy to answer them and take suggestions. And thanks for watching. See you next time.